Algebra 1 skills number 38, graph transformations. All right, so first we're going to look at the concept of a parent graph. Parent graph is the simplest graph of a family of functions. And in Algebra 1, we don't have that many functions. In this particular video, we're going to show the quadratic or parabola family. With the parent graph, there are no transformations applied, so it's kind of like where you start. It's the default graph. And here is the parabola that you probably have already seen at this point in the course. But this is the y equals x squared family. Notice that the graph has a vertex at 0, 0 here. First, we'll look at shifts. Shifts is when you move the vertex of a graph. If you add on the outside, you go up. If you subtract on the outside, you go down. If you add on the inside, you go left. And subtract on the inside, you go right. Okay, so of course there's some memorization that's going to take place here. Here's an example. So we have y equals x squared, therefore it's the parabola family, and this red plus 2, this is adding on the outside. So notice that the blue parent is still graphed, and the red transformation is the same graph shifted up 2. Now it looks like it's more narrow, but it's not. It's just we're only seeing the sort of bottom portion of it, or we're not seeing as much of the red as we are the blue. But the 2 made it go up 2. Okay? If you subtract 2, that's on the outside, it's going to go down. So again, you can see the blue parent versus the red transformation. To be on the inside means to be on the inside of the function. The function here is to square, so the plus 2 is actually part of the squaring. This is adding on the inside, and we go left. Again, blue is where you start, or it's the default graph, and the red is the transformation. If you subtract on the outside, you go right. So notice to move the vertex, you must add or subtract somewhere in or outside the function. You could do a combination. So in this case, you're subtracting on the inside and adding on the outside. So notice it went both right 1 and up 3. It's often here, and really in any of the problems so far, to where you can think that on the inside, you change the sign to 1. On the outside, you leave it alone. So the point 1, 3 is the vertex. Okay, and there's that coordinate. So again, change the sign on the inside, but not on the outside. Okay, we also have vertical stretches and shrinks. Shrinks are sometimes called compressions. A vertical stretch is going to be steeper, or in some cases you can think of it as more narrow. That's when you multiply by a number that's either bigger than 1 or less than -1. A shrink or compression is going to be flatter, or in some cases wider. It's when you multiply by a number between 1 and -1. So again, there's the parent graph. Here we're multiplying by a number that's bigger than 1. Okay, therefore, it got more narrow. This is called a vertical stretch. It's clearly more narrow than the original blue parent. Here we're multiplying by a number less than 1, or you can think of as between -1 and 1. This is therefore a vertical shrink or compression. Notice this time the graph got wider, or you could think of it as kind of pressed down upon it and therefore flatter. But a number less than 1 makes it wider. A number bigger than 1 makes it more narrow. And that, when I say bigger than 1 and less than 1, the negatives are not part of that. Okay, you ignore the negative when it comes to stretch versus shrink. A reflection is when you multiply by a negative number and it reflects over the x-axis. We kind of use that loosely. To truly reflect over the x-axis, you have to multiply everything in the function by negative. And sometimes we think of it more as flipping upside down. And there's that idea. If a negative is only applied to the leading term, it flips upside down. So we're thinking of flipping upside down or reflecting over the x-axis. That's not necessarily the same thing, and there is a distinction there, but a negative in front is going to make the appearance be upside down. Okay, so here we have 3 looks. We have this is not the parent. This is the parent that's lifted up 1. Okay, just that simple shift. The red is a true reflection over the x-axis because we changed the sign on both of them. Okay, so therefore it's like you folded over the x-axis right here, and the blue just folded down to the red. On the green, you only made the first term negative. So it still has the upside down appearance. It's just the first term became negative there. Okay, and we can have several transformations apply at the same time. So remember our idea of changing the sign on the inside but not on the outside. Now that -2 has nothing to do with the shift. So we're going to go to the point 3, 4. We're also going to make it more narrow, and we're going to reflect, or at least flip it upside down. Okay, so let's see that in action. There's the point 3, 4. Again, changed on the inside but not on the outside. It got clearly more narrow. The blue is the parent, the original, and the red is clearly more narrow. And the negative made it flip upside down. Okay, so you can have several transformations applied at once. Okay, so that is graph transformation.